Hello everyone. So we've been spending some time lately in this unit on momentum, and one type of physical situation where momentum is very useful is in studying collisions between objects. So in this video, I'm going to be introducing the first of two worksheets on collisions as a number of problems for you to work out. And what I'm going to do is I'm going to work through the first four problems showing full solutions and answers, and then I will leave the rest of them for homework. And as you're watching this video, I would recommend after you watch the first one or two problems that you start pausing the video and maybe try to work problems 3 and 4 out on your own before seeing the solution as a way of checking your understanding. All right, so before I start into problem number 1, let me just summarize some of the major ideas that are going to turn up here. So first of all, let me just remind you the definition of momentum. So P stands for momentum is equal to mass multiplied by velocity. Second idea, closely related to this, is you need to remember that velocity can be positive or negative. And that's going to depend on which direction an object is going. So as you're writing down your equations, you always need to keep in mind what direction objects are going so that you know if the numbers you're plugging in for velocity should be positive or negative. And I guess technically there is a third option. It could also be 0 if an object is not moving. All right. Third big idea is that whenever there is a collision between two or more objects, we can say that the momentum before the collision is going to be the same as the momentum after the collision. And when I say momentum, that means the total momentum of all of the objects involved. And then maybe a fourth idea is to always draw figures. So some of the problems on this worksheet show figures, but you should always draw a figure with arrows that represent the motion of the objects. So the arrows give you a nice visual cue so that you can look at and see if the object has a positive velocity or a negative velocity. All right, so let's go ahead and jump into the first problem here. So we have a 5 kilogram ball that is thrown with a velocity of 15 kilometers per hour, and it's thrown at a 50 kilogram skater who is at rest. And the skater catches the ball and slides across the ice. All right, so if I were to draw this, I would make a before and after picture. So I maybe show the ball here. So that has a mass of 5 kilograms, and it's moving in this direction at 15 kilometers per hour. And then the second object in this collision is the skater. So this person has a mass of 50 kilograms, and they're at rest, so I don't draw any arrow to represent that they're not moving. All right, so that's my before picture. And then after, the skater catches the ball and they slide across the ice. So this is what we would call an inelastic collision, or a totally inelastic collision, where the two objects stick together and then move as one. So in the after picture, I can actually just draw one object and say it has a mass of 55 kilograms. So it's 50 for the skater plus the 5 kilogram ball that they are holding. And they're going to slide in this direction at some unknown velocity. All right, so to solve this, I'm going to use item number 3 up above that says the momentum before the collision is equal to the momentum after the collision. I'm also going to take a shortcut here. You may notice the velocity here is given in kilometers per hour. You may think that it's necessary to translate that into meters per second, but as long as I give my answer in kilometers per hour, one handy shortcut that turns up in these types of problems is you can actually stick with whatever units you want for velocity as long as you use the same units throughout. All right, so I'm going to write the momentum values down below my figure in a different color. So for the ball, we have a mass of 5 and a velocity of 15 before the collision. So 5 times 15 is 75. And then the skater is at rest, so their momentum is 0. All right, so my total momentum before the collision 75 plus 0, so that's just 75. So that means my momentum after the collision must also be 75. Now I only have one object after the collision, so the momentum of the 55 kilogram object is going to be the mass, 55, multiplied by the velocity v. All right, so I have an equation that I can solve now. 75 equals 55 times v, so that means v is going to be 75 divided by 55, which is about 1.36. And since my velocity was in kilometers per hour on the left-hand side of my equation, this is also going to be kilometers per hour. Now, if the problem explicitly asked for the answer in meters per second, then we could do a conversion here, but I'm not going to be concerned with that for this worksheet. All right, so number 2, we have a large fish in motion at 45 centimeters per second, encounters a smaller fish which is at rest, and it swallows that fish and continues moving forward, and we want to find the velocity after the collision. All right, so this is really the same type of problem as number 1, just with different numbers. So if you want, you might actually pause the video here and try to work this one out on your own before you see the solution. All right, so I'll go ahead with that. So we have our large fish here. This is 1 kilogram moving at 45 centimeters per second. And then we have our small fish, which is 0.25 kilogram, and it's at rest. So again, no arrow attached to that one. And then in my after picture, again, this is another type of totally inelastic collision. The two objects stick together, so to speak, if the large fish swallows the smaller one. So I can just combine these into a single object. The large fish now has a mass of 1.25 kilograms, and it's going to continue forward. All right, so if I look at momentum, over here I have 1 times 45. I'm leaving the units off here, but that would be kilograms times centimeters per second in these units. For the small fish, the momentum will be 0. So total momentum before the collision is going to be 45 in these units, which means that the after momentum must also be 45. All right, so again, we only have one object, so the momentum is mass times velocity. So it's 1.25 kilograms times v. And that means v is equal to 45 divided by 1.25, which is, looks like exactly 36 centimeters per second. Okay, so number 3 is going to be a little bit different. The second object is not going to be at rest this time. All right, so let's see how that one works. We have a 4,800 kilogram truck. So m equals 4,800, traveling with a velocity of 4 meters per second. And that collides head on with a 1,200 kilogram car. And that's traveling with a velocity of minus 12 meters per second. So the negative velocity tells you that the car is going in the opposite direction. And also the term head on here also implies that the two objects are moving in opposite directions. All right, so we have velocities of 4 and minus 12. All right, and then they crash and then they entangle and move together after the collision. So this is yet another totally inelastic collision. So we can just draw a single combined object afterward. So the mass here is going to be the mass of the truck plus the mass of the car. So 4,800 plus 1,200 is 6,000 kilograms. And this one, this time we actually don't know ahead of time which direction it will be moving after the collision. So we'll have to just go through the math and see what value we get for v. Okay, so again, next thing we do is calculate the momentum for each of these objects. So for the truck, we have 4,800 times 4, that's 19,200. For the car, we have 1,200 times negative 12, which is negative 14,400. All right, so the total momentum before the collision is going to be the sum of these two numbers. So 19,200 minus 14,400 is equal to 4,800. So that must be the momentum after the collision. So 4,800 is going to be the mass of our combined object, which is 6,000, multiplied by the unknown velocity v. So velocity is going to be 4,800 divided by 6,000, which is 0.8. And all of my velocities were in meters per second for this problem, so my answer is also going to be meters per second. All right, so how do we know what direction this clump of cars is going to move in? Well, we know that a positive velocity means moving to the right and a negative velocity means moving to the left. Our velocity came out positive, which means that it's going to be moving in this direction. That's because the truck has more momentum in the rightward direction than the car had in the leftward direction, so the truck is going to win that collision, so to speak, and it's going to drive the car forward in the original direction that the truck was moving in. All right, so last problem that I'll work out here. This one actually gives you a diagram to start with. So we have two balls that are rolling on a frictionless surface and they collide with each other and bounce. This time they do not stick together after the collision. So this one's going to be a little bit different from the first three examples. So we're just trying to find the unknown velocity of the 6 kilogram ball after the collision. We don't know, does it go to the left or to the right? Can probably guess from context, since it was going to the right to begin with, and then it was hit from behind by a second object, it's probably going to continue going to the right. But in general, we won't always know that. Okay, so the way we would start this problem is calculate the momentum of each object first. So for the smaller objects, the momentum is going to be 3 times 6, so it's going to be 18 kilograms meters per second. Again, I'm leaving the units out here just to save space and make this easier to read. The momentum for the second one is going to be 12 kilogram meters per second. Both of these numbers are positive because both objects are traveling to the right. So the total momentum before the collision is going to be 18 plus 12, so it's going to be 30 kilogram meters per second. All right, so over on the after side, we have a 3 kilogram ball moving at 3.5 meters per second. So if you multiply those two numbers together, you get 10.5 kilogram meters per second. And then the momentum of the other ball is unknown because we don't know how fast it is going. But we do know that the total momentum after the collision must also be 30 kilogram meters per second because it has to be the same as the before momentum. So that means if we add these two numbers together, 10.5 and some unknown value, we have to get 30. So this is just a subtraction problem. What number must you add to 10.5 to get 30? And the answer is 19.5. All right, so we know the momentum of the 6 kilogram ball is 19.5, and we know that's equal to its mass, 6, multiplied by its velocity, v. So final step is to solve this equation. The velocity is 19.5 divided by 6, which is 3.25. And units will be the same as all of the other velocities, so that would be meters per second. All right, so hopefully you're getting the idea on how to solve these problems. Go ahead and try the rest of them for homework, and the answers can be entered into the It's Learning assignments. All right, thank you for watching.